Yeah. All right, give me a
I thought
second.
we were
So,
doing the seismograms.
yeah, we did that yesterday too, but we went over the first one, and I'll show it again too,
Okie dokie.
really quickly, so we can get the seismogram stuff. The history of life sequence. Yeah. So your first, hold on, I'm looking at the paper. Station one. That answer key was, I think it was the first thing I'd posted yesterday. So when you go down to week 3, the history of life sequence. Yep, that one. Station 2 was the interactive, go play tectonics and stuff. Station 3, where it's the Ring of Fire mapping. It was just like copy and paste a picture of the Ring of Fire, not Mordor. Station 4 is types of rocks. That one, I accidentally put it up as Station 5 because I can't count. I took out the 2 lab stations, so I forgot to change this. But types of rocks is right there. And then the Pangea puzzle, like just do a picture of Pangea. And then Station 6 is this epicenter thing that we were working on yesterday. So I hope that helps.
Yeah.
Do you have any other questions, Naija? Okay. Oh, we'll be able to get you guys started. Of course. There it goes. And there's the ceiling of my classroom. Welcome. All right. So we were working on this the other day, so you should recognize this lovely thing. Um, and then we were working on the table. So we got almost all the way through the table. Did you guys need any help at all in, or any reference to what we did yesterday? Do you remember?
I think I might need a little more practice on the graphing part.
The graphing part?
What do you call them? When you match the lines up with the lines.
Like this line right here with this one?
No, I mean, on the graph paper with the yellow sticky note.
Oh, sorry. Got you. Yeah, I see what you're saying now.
That was confusing.
Oh, guys, I gotta turn off my Pandora. I forgot. So we're gonna actually, yeah, because we only did one of those yesterday, so we're gonna definitely do some more today. Why did this get all weird when I did that? I just want to get to my. Fine, I'll go the long way. Um, okay. So we got this far yesterday when we were getting um, the distance to epicenter. The important part was finding this lag time, the difference between the P wave and S wave, and I call that lag time, if you guys remember what lag means, just in general. No yawning. Uh, so we found it by finding the distance of the times. And then for the distance to epicenter is where we had to take that 4 minutes and 50 seconds and measure that out on this. So it's so weird to watch because there's definitely time lag. So this is where, there it goes. This is where I marked out approximately 4 minutes and 50 seconds on my scratch paper. So I put a mark at 0, and then I put a mark right around 4 minutes and 50 seconds, almost to the 5. And then that is where I had to kind of scoot this and match it against my P and my S wave lines. So this is how fast they travel. And then like down here, these two lines don't match up with my P and S lines. Up here, they don't match either. So I had to find that sweet spot, which was right around here. So if you can see that this line matches up here, this line matches up there, that's when I would follow this line down to the bottom of my graph. And remember, this is each number here. This is 1,000, 2,000, 3,000, 4,000, 5,000. Each one of these boxes is 200, so it was 3,400 was how we got the distance for that first one. All right, so for the next one, I don't remember what it was. 2 minutes and 50 seconds. So I'm going to take my paper. I'm trying this from a different angle today, so I'm getting a little confused. 2 minutes and 50 seconds. Again, it's going to be kind of an estimate. This is 20-second bars, but I know I'm going to be almost to the 3. So there's my 2 minutes and 50 seconds. Hopefully you guys can see my marks on here. All right. Then you're going to work your way up. I will tell you the biggest mistake people do is they start going like this. And so when it becomes sideways like that, you're not actually getting a distance because now, oops, you're getting 2. So you've got to keep your scratch paper straight. So it's still inside the 2-minute line, so I got to get small, or 2,000 kilometer line. Yes, it's measuring in kilometers. And that's my key right down there. My graph tells me it's in thousands. That's times 10 to the 3rd kilometers, which my hand is probably blocking most of that. So right here on this line, it matches up, and so as close as we're going to get at least. And so when I follow that line down, it's going to come to about right here. What do you guys think that is in kilometers? Good, 1,600. Very nice. All right, so then I'm going to go back to my thing. And I'm going to put 1,600. All right, so we've got one more. It's at 3 minutes and 30 seconds. Good thing my Post-it note has 4 sides. All right, so 3 minutes and 30 seconds. I'm going to line up my sheet. I'm going to mark 0, and I'm going to go halfway in between the 3 and the 4. That's my 3 minutes and 30 seconds. And then just knowing that that lag time is more, I'll go back here really quick. Just knowing that this lag time is in between these 2 lag times, my distance is also going to be in between these 2 distances. So if I get a number smaller than 1,600 or a number bigger than 3,400, I'm doing something wrong. So it should match up relatively. So 3 minutes, 30 seconds, and oh, this is the sticky side. Oops.
So when you draw out the lines, you just go up 20 seconds until you find the right time?
Yeah. You kind of have to estimate it. There's a lot of rounding in this.
Oh.
All right, so I've matched up my two lines again. It's relatively straight. So when I follow it down on my graph, I come to here, which is how many kilometers?
No.
This one right here. Good, Joshua for the save. It's 2,200 kilometers. That's one line in. I told you guys that each line was 200 kilometers. So back to my 2,200 kilometers. All right, everyone good on that?
For now.
For now. See, if you guys were in earth science, you would actually have to do this all the time.
I took that back in 8th grade.
Yeah. What do you mean you didn't get the ones yesterday, Josh Rick?
Miss Miller, please report to the gymnasium. Miss Miller, please report to the
What is that?
gymnasium.
That is the office telling Miss Miller to please report to the gymnasium. See, there's interruptions, just like there is normal school.
Still?
Oh yeah. Is that what you needed, Josh Rick? Is the times? All right, so I'll leave them right there for a second. So the next part we get to do is mapping it. So we actually have to put circles on the map. You guys can just do like an estimated circle in Word after I draw one, but I get to do all the hard work. So hopefully, I don't know if you can see that part of my screen while I have Word up. You guys have seen one of these before?
Called a protractor.
Called a protractor, very nice. I have a pin, sharp metal point on one side, pencil on the other. And then still kind of in view, you guys have a scale on here. So it tells me in kilometers, so I don't have to do any conversions from like meters to kilometers or anything, because we already did this all in kilometers. All right, so I meant to leave that up. Oops, sorry. So the first one we want to look at, we're going to look at Balboa Heights, and we need to draw something with a radius of 3,400 kilometers. So Balboa Heights and 3,400 kilometers. So Balboa Heights is all the way down here, Panama. And then I've got to measure out with my protractor 3,400. Granted, this is going to be very estimated. I put my pin on 0. Hi.
Doesn't give you a key.
I
mean, like, say for instance on like the wall poster maps, you get like 1 inch equals like 300 kilometers or something like that.
Oh, yeah. Nope. We're keeping this one simple. I do have much harder ones than this, but we're keeping this simple. So I've got my metal pin on 0, and then I've measured out to 3,400 kilometers. All right. Then this is going to be really weird to do. I have to get like super awkward on my desk. I try and hold this. This one doesn't have a locking. And then I draw my radius of 3,400 kilometers. I don't have to draw a full circle because the map is not complete. But there's where our first line from B should be. So that's from Balboa Heights.
Are you supposed to draw that?
So you'll have to do like a circle or whatever on your Word document. What is it? Where insert,
Insert a circle.
yeah, shape.
Okay.
And like I said, your guys' is not going to be perfect, and I get that. So it'll be something. And you'll obviously want to change the color. I like what I just did. But it roughly goes about right there. And then you can change it so there's no fill. So you just get the line.
Okay.
See how that works for you guys?
On my side, I click insert, but I don't see any shapes.
So insert, and then it'd be right there. All right, I'm gonna go back to my table and get my second measurement, which is 1,600 kilometers from Boulder, Colorado. Yes, we have seismograph machines here. That was kind of redundant to say, but 0 to 1,600. So I just had my pin on 0 again. And now I'm going to make a radius or a circle with my 1,600 kilometer radius. Again, this is super awkward. I'll probably end up disconnecting my phone. Yeah, maybe not. I might be lucky. All right. So I've got my second circle. I now have 2 places where these lines intersect. So when I say triangulation, we need 3 points because now we've narrowed it down to 2. The earthquake could have happened at either one of those points, but the third one will tell us which one of those 2 points it is. Anyone lost?
Little bit.
On what?
Let's see. You already started on the second one. I was still on the first one. Let me catch up.
Right. So remember, the whole purpose of finding that lag time is so we can figure out how far away from the epicenter it is. So when we're looking at just Balboa Heights, that meant anywhere along this line, that earthquake could have happened because it would have taken that long to get to Balboa Heights. Yes, hold on, Kilajne. And actually, just so maybe you can see both. So you can see my circle up here, and now there's one right in here. I can insert, and of course, it shrunk on the shapes. A circle. Again, I know I'm not drawing on here perfectly, but come on. I'm trying to move too fast for my computer, I'm sorry. All right, so I've drawn on my second shape.
That is very precise. Mine is worse.
And keep in mind, if we were doing this by hand or doing this in class with actually you guys having these things in your hands, like we're rounding to the like 100th kilometer, and we're rounding our times. So there's gonna be a margin of error in here as well. You're not gonna get perfect, generally a very perfect intersection, but it'll be close enough. Can I move on to the last one? Everyone good? So much silence.
No.
All right, thank you, Naija. All right, so our last one is 2200. So coming back here, getting my scale, I gotta count to 2200, which is about right there. And it was from Mexico City. So I'm gonna draw from my circle from the center of Mexico. Oops, I made an error.
What happened to your circle?
I accidentally pinched my protractor.
Uh-oh.
That's what happened.
It's an
So,
earthquake.
yeah, I was down to like 1800. So rather than holding, because like I said, this is one of the ones that does not lock. And I'm trying to maneuver around cords and my computer screen and my phone, because my phone's my camera for this. All right. So, like I said, you would not come up because of all the rounding that we did. You would not come up with a perfect intersection. If you do, it's generally by chance. But we know that our earthquake happened somewhere in that shaded area. Kailajane, you just have to, hold on, let me get my word back. When you do the fill for it, oops. So I have my fill option right here. You have to click no fill and you'll be able to see through it like you can on mine. All right, so I'm going to go back to this one. We know that this is now our epicenter. This is where the earthquake originated from, just somewhere south of the Great Lakes. So like Kentucky-ish, or no, Tennessee, sorry, is on that one. Ohio, Indiana, somewhere right in there. I don't remember what's right below. All right. So we've narrowed it down. That's the triangulation. That is how we can find the epicenter of an earthquake. Not the focus, but the epicenter at least. And then, yeah. So that's it for the finding the epicenter, the triangulation. And where this is all coming to, especially if you haven't touched any of the web quest yet, that's homework, is earthquakes are a support for plate movement. Many years ago, people thought the earth was 100% static. There was no movement of plates. There was no Pangea. Anyone who thought that way was ridiculed and made fun of because they didn't believe real science. And it turned out this is real science. So your earthquakes, your volcanoes, which is your mantle movement and releasing pressure, all that stuff is your support for your plate tectonics and continental drift theory. And now you know how your cell phones work as well. All right. Okay. Can I move on, or do you guys need another second so you can see the circle?
You can move on.
All right. All right. So we're going to start this part right here in your packet. and we're going to talk about soil formation and erosion and the soil layers. And let me get my PowerPoint up.
Soil.
Yep. And so your DOL is open for the plate tectonic stuff. Again, it's not due until Saturday, so if you want to finish like your web quest and stuff first, that's fine. It doesn't have to be done today. I'm not going to look for it until the weekend. The next one that'll open up like tonight or tomorrow, the next two are on soil. So dirt is very important. All right. Oh my gosh. You and your obsession with donuts. All right, so another little bit of review from earth science, if you took it, is weathering and erosion and deposition, really. The weathering means it's a breakdown. It's just the breaking of rocks, continental, oceanic crust, whatever it may be. It's just the breaking. You do have a couple different types. One is called physical. It's also called mechanical weathering. And that's that physical breaking. Like I take a hammer and break a window. That is physical weathering or mechanical weathering. Do you guys remember what abiotic and biotic means from biology? Maybe. You can say no, it's okay, especially if you took biology last year.
Repeat that?
What's that?
Can you repeat it?
What does abiotic or biotic mean? If you had biology last year, this would have been covered in the spring, but we had COVID, which canceled, and we weren't allowed to teach new things. So you wouldn't have gotten it, but if you had biology before last year, you should know this. Yes, I will, Kailajane. I'll do it right at the end of class. All right, so abiotic, well, I'm going to start with biotic. Bio means life, right? So it's living things. Abiotic is the opposite. It is non-living things. So your biotic causes down here, it says plant roots, burrowing animals. Plants and animals are living. So they can break things down by, break the rock down. Sorry, I lost my train of thought. Break the rock down, and they're biotic. They're living. Abiotic causes water, wind, temperature. They can break rocks, especially since a lot of you probably drive, how many potholes there are in this city on the stupid roads. That all mostly comes from temperature variations in water. So they come from abiotic causes. All right. When you get that physical breakdown, it increases surface area, and that leads to even further breaking down. All right, so here's an example of, it's called ice wedging, which is a type of physical weathering. Water collects. The water, just like an ice cube, expands when it freezes, and then when it thaws, the water's able to dig down in those cracks that was caused by the ice, and then eventually you end up with stuff like this. All right. Oops. The next one is chemical weathering. Chemical weathering usually means there's some sort of change in the actual material itself. So it releases nutrients from rocks. So some of your iron, your phosphorus, things like that. And like it says below, it's an important part of the phosphorus cycle. I think the easiest example for me is if I were to stand here and rip up a piece of paper. That ripping is physical. It's still paper. It's just now in two pieces. If I take a lighter to the piece of paper and it starts burning and it turns to ash, that's a chemical change. That ash is not the same as the paper. So that's kind of the difference between the two. This is how things like cave of the wind forms, as well as chemical weathering, not mechanical. You're going to hear this word a lot, anthropogenic. Anthro means like human. So like anthropology is the study of like human history. Anthropogenic means it's caused by humans. So we have human-caused chemical weathering. A big part of it, for example, comes from fossil fuel combustion, the buses, cars, all that driving around, or, you know, burning for energy. Like we have our coal plant downtown. That releases sulfur and nitrogen oxides, which you'll hear, especially once we get to atmosphere, referred to as NOx and SOx, SOx for sulfur oxide, and NOx for nitrogen oxide. They react with the water that's in the air and create sulfuric acid. That sulfuric acid creates acid rain. And Colorado is one of either, I forget, 2 or 3 places in the US that gets a heavy amount of acid rain. All right. Hopefully you guys have heard of acid rain before. And if not, what does it do? So we have statues that are typically made of limestone or marble. You have marble Colorado, which is one of 2 places in the entire world with white marble, and is part of responsible for building the Washington Monument, things like that. Acid rain affects them. It'll start to completely degrade. Yes, I already know it's a pixelated picture, but lady lost her face, basically. That's what happens. The acidification of soils. So you guys hopefully are very familiar with pH already. Your water tends to be close to a 7. And then like your orange juice and your sodas are acidic. Bleaches and cleaners are basic or alkaline, so they're higher on the scale. And certain plants can only grow in certain pHs, so it makes a difference there. Impaired visibility, so almost like what the forest fires giving us lately, but with pollution instead. And then acid rain can cause issues with people with asthma, bronchitis, emphysema, any sort of respiratory problem. I'm actually going to stop here. We'll start this tomorrow so I can show you guys how to get to the DOLs again. If I can even there we go. Oh, I have to verify my identity. Yay. So you have to go into your AP Classroom. You can even just Google AP Classroom if you want. Or if you don't want to Google, it is on your homepage for here. And it's AP Classroom right there. And then, oops, I have to go. Sorry, I have an extra step. You guys might not have to do this part. I have a lot of extra steps. And then your homepage should look a little different than mine as well, if it ever loads. Oh my Lord. There it goes, slowly but surely. It should just be on your home page, but it'll say like DOL number 1, and then later on in the week it'll say DOL 1 with today's date, DOL 2 will come tomorrow, and so on. All right, so that's how you get to it. Yours right now will only have this one.
All right.
All right, so that's it for today. I'll see you guys tomorrow. You're welcome.
Thank you.
Miss Peterson?
Yeah.
Can you go back to acid rain effects?
Yeah. Mm. There you go. Bye, Dante. Bye, Nasia.
And then physical, and then that's all I need.
Physical, right here.
Thank you. Have a good rest of your day.
Thank you, you too. Jalen, you good?